I am excited to introduce the esynergy Collibra Adaptor. At esynergy, we have developed the Collibra Adaptor as a game changer for your data governance integration. This accelerator simplifies the process, automating the population of both logical and physical metadata and linking them to create a single global view of your data. More importantly, it brings data owners and stewards directly into the governance process as part of the deployment lifecycle, enabling proactive and efficient data governance. In this demo, we showcase the esynergy Collibra Adaptor using a specific technology stack. The adapter leverages Collibra as the data governance platform and gathers metadata from dbt, one of the industry standard frameworks for data transformation. For this demo, we are using dbt Core, the free and open source version of dbt. The esynergy Collibra Adaptor is designed with flexibility and extensibility in mind, and is already evolving to include capabilities such as pulling metadata from data contracts and integrating with other data governance platforms like Microsoft Purview. These features are currently in development. The data platform used in this demo is Snowflake. We have configured the out-of-the-box Collibra connector for Snowflake to synchronize physical metadata into Collibra. Collibra also supports connectors for many other data platforms, making it adaptable to your specific needs. We are also using Apache Airflow as the orchestrator to schedule jobs. However, this decision is fully flexible and any scheduling platform can be used as long as it supports scheduling the execution of Python scripts. This data governance setup serves as an example and can be fully customized to meet your unique requirements. It aligns with your data governance meta model in Collibra, and it supports additional approvals and adjustments in the data governance process, as long as the minimum requirements are met, such as, for example, mandatory attributes like e-tags within assets to easily identify changes. The first step in this demo is the onboarding of a new data product, which involves several key actions. This includes creating the data product in Collibra, deploying the esynergy Collibra Adaptor linker as a background schedule job to automatically find and link logical and physical metadata, setting up Snowflake by creating necessary databases and schemas, and configuring the Collibra connector for Snowflake to ensure proper synchronization of the physical metadata within Collibra. Additionally, we have to provision a code repository to operate the framework. In this demo, we are using GitHub, but the framework is flexible and compatible with any code management platforms. Let's start by creating the data product in Collibra. We are going to create this data product under the data mesh business asset domain by clicking create product. The naming convention must include versioning, as this allows us properly manage changes to the data product over time while maintaining a clear change history and lineage. Once a data product is published in production, its version becomes immutable. Any changes to main attributes will require creating a new version. The esynergy Collibra Adaptor streamlines this process, helping you create new versions and ensuring the integrity of the process through the entire life cycle. While these rules and restrictions can be customized to meet specific requirements, we strongly recommend following this practice to maintain consistency and governance. So let's create the data product. Okay, so the data product has been created and is in the status draft. So now we need to provide all the relevant business metadata to ensure the proper definition. So if we click in here, we will need to provide all the required attributes based on your specific needs. As this is an example, we are gonna just add some placeholders. The next step is going to be to identify the responsibilities. It's required to identify the data owner, who is the business owner responsible for the data steward, who manages the data product on the day-to-day basis, assisting the data owner from the business side, and the data custodian, who is the technical owner responsible for implementing the data product using the appropriate frameworks. These clear role definitions ensure a smooth collaboration between business and technical teams, aligning the data product with both business needs and technical standards. In this case, I'm gonna assign it all to me, as this is a demo, but in a real example, those roles will be assigned to different people in order to govern properly this data product. We have assigned all the responsibilities properly: the business steward, data custodian, and owner. So now the last step is to tag this data product as ready in order to initialize the Collibra workflow to promote the status of this data product. So now we have properly created the data product, and this data product is already pending for approval. Then we will deploy the esynergy Collibra Adaptor linker, which is a background schedule job that automatically finds and links logical and physical metadata. For this demo, we are using Apache Airflow as the scheduling service, but the process is flexible and can be configured to work with any other scheduling platform. Bear in mind that the physical metadata will be populated in Collibra using the out-of-the-box Collibra connector for Snowflake, while the logical metadata will be populated by the esynergy Collibra Adaptor, as you will see in this demo. The linker will then associate the physical metadata with the logical metadata. Without this linking process, the two metadata types will remain isolated, preventing the creation of a global view that connects logical and physical metadata, a critical component of effective data governance. In this screen, you can see that this process will be running in the background during the entire demo. The next step involves setting up Snowflake by creating the necessary databases and schemas for each environment for this data product. In this demo, we are using the same Snowflake instance across all environments for simplicity. However, in a real setup, it's a best practice to use separate Snowflake instance for each environment to ensure isolation and compliance. So let's execute this script to create the resources. And now we can see the resources has been properly created. Finally, let's take a look at the GitHub repository we will use to operate the Git framework. This repository contains the DBT resources and the GitHub actions. It's important to mention that esynergy Collibra Adaptor is designed to integrate seamlessly with your existing pipelines. So there is no need to create new repositories if you already have one in place. These pipelines are critical for validating the deployment status across the different environments. In this demo, we are working with three environments: dev, UET, and prod, and types of pipelines: the pull request and the deployment. The pull request will guarantee that all the requirements are met before allowing any deployment in this specific environment, and the deployment pipelines will promote those changes to the environment once all the requirements are fulfilled. Then the pipelines ensure the consistency of the data governance process by tightly coupling it with the deployment pipeline. This guarantees that all the data governance requirements are met before any changes are allowed into production. This approach embodies what we call proactive data governance. It requires business approval for any data change before they are deployed to production. Additionally, we are using dbt as processing framework. Within dbt, we are not just defining our data modeling and the SQL that we are going to use to implement the data transformation, but we are also embedding logical metadata provided by the data steward, like business descriptions to define each entity and attribute, display name that is going to be the name we are going to use within Collibra to define these entities and attributes, or if the attribute has PII information, versioning, or any additional logical metadata the data product will require in order to be properly governed. Once the onboarding is complete and the first iteration of our data product is developed, we are ready to proceed with the first deployment in the dev environment. The process is straightforward. We just need to create a pull request to merge the changes into the dev branch. In this case, I'm gonna just create a PR with a dummy change, as I already have all the required data modeling and assets within the repo ready to be deployed. So we are gonna create a PR. When we create the PR, the pull request pipeline is gonna be triggered automatically in order to check that the data product is created and is in pending status, indicating that the data product has been created and the data steward has been notified. It's worth mentioning that in this example, development can begin even before the data steward finalizes the full definition of the data product. The only requirement in this implementation is that the data product must be created and at least in a pending for review status, meaning the data steward has been notified, but approval might still be pending. This approach allows teams to familiarize themselves with the framework and tooling in dev environments. This workflow is fully customizable to meet your specific requirements, so this behavior can be adjusted as needed. The goal is always to strike a balance between maintaining agility and enforcing rules that ensure both business value and proper data governance. It is important to mention, as this is a demo, we have disabled the approvals to merge the PR, but in a real setup, some approvals will be required to merge this PR. So then, once the validation is complete, the final step is to merge the pull request. This action deploys the changes to the data governance, populating all the data entities and data attributes with a draft status within the newly created data product in Collibra. At the same time, the updates are applied to the data platform, Snowflake in this case, using dbt. So let's check in actions and we will see that the deployment pipeline is already running. As we can see here, the process finishes successful, so we can come to Snowflake and we can see all the assets has been created, and if we go to Collibra, we can check the data product we just created. It contains the three data entities we defined previously on the GitHub repo. And if we go inside, we can see that the status is draft, as it was only deployed in dev. And it also contains all the business description and logical metadata we previously defined, and all the data attributes included within this data entity. So all the logical metadata has been properly deployed to Collibra by the pipelines. Once the development is finished and ready to be promoted to UET, the process is almost identical to the one we used to deploy in dev. However, this time the requirements are slightly different. If we attempt to merge directly from dev to UET, the pull request will fail because the data product and the data entities haven't been approved yet. So let's try to create the PR. As you can see, we are not able to merge this PR because the validation has failed. For promotion to UET, the data steward must approve the data product and the data entities. This approval process is managed within Collibra and implemented by the Collibra workflows. If we log in Collibra as a data steward, we will see we have some tasks pending for review. Those tasks allow us as a data stewards to approve the data product and the data entities. So let's approve all of them and retry the validation. Now all the all the data entities and the data product have been approved. So if we check again the data product, we will see that is on approved status. So now let's come back and retry the validation. By the way, the logs shows that the issue is because it was pending for approval. So now the validation process has been completed successfully. So if we go back to the pull request, we will be able to merge it. It's important to mention that the validation process defined in this demo can be customized to your specific needs. As part of the esynergy Collibra Adaptor, we provide a simple Collibra workflow to implement the data governance process demonstrated in this demo. However, it's fully customizable to fit the specific requirements and process defined within your organization, as every organization has unique needs. For example, as part of this approval process, we can incorporate steps to link business terms with data attributes. This linkage can be achieved through the Collibra workflow or by performing manual actions within Collibra. However, we strongly recommend to using Collibra workflows as much as you can to streamline this process. In this scenario, alerts will be sent, as you saw, to the data stewards, prompting them to review and approve the data product and entities. Once the data steward provides the approval, the status of the data product and entities will change to approve. At that point, we can rerun the UET check, enabling us to merge the changes into UET. It's important to note that the UET deployment job doesn't make any change to Collibra metadata. Its only purpose is to validate that all the prerequisites are fulfilled and the metadata has been approved before proceeding with deployment. Merge the PR in order to deploy the assets to UET. After merging, a new GitHub action will be triggered to manage the deployment. While we wait for the deployment to complete, I would like to mention that the esynergy Collibra Adaptor also checks for changes in the UET deployment, as changes are only allowed in dev environment. So if you try to change something and deploy it directly in UET, by default the validation will fail, preventing those changes to promote directly to UET. Obviously, this is something that can be skipped or configured, but it is a good practice to prevent any changes deployed directly in higher environments without properly testing and deploying in previous environments. As you can see, the deployment process has completed successfully. So if we come back to Snowflake, we will be able to see in the UET database all the assets deployed. And if we go back to Collibra, all the data product and data entities and attributes will stay the same in approved status, waiting for the production deployment. Finally, for deployment to production, we follow the same process once again. However, this time there is an additional requirement. All logical and physical metadata must be linked. This step is handled automatically by esynergy Collibra Adaptor linker and the Collibra connector for Snowflake. We have scheduled those two processes earlier in this demo. So let's check. As you can see in Airflow, the linker was running the entire time of this demo, and it was linking the physical and logical metadata. While in Collibra, we have set up the Collibra connector for Snowflake, which has synchronized physical metadata from Snowflake automatically. So now let's create the PR from UET to prod in order to finalize this production deployment. Once the PR is created, the validation process will start in order to check that the physical and logical metadata is linked. As you can see, the validation process has completed successfully. So now we are able to merge the PR in order to start the deployment process to production. So let's merge the PR. Once the PR is merged, a new GitHub action will be triggered in order to deploy assets to production. Okay, the deployment has completed successfully. So now we can go back to Snowflake, and if we check the production database, we should be able to see the tables. And if we go back to Collibra and we check the data product, this must have all the status as published for the data product and for all the entities within this data product. Now that the data product has been published, we can view it in Collibra along with all its associated data entities and link it physical metadata that implements the logical and physical model in the data platform. This provides a comprehensive global view and ensures full traceability of all your data. So let's start by coming to the data product. In here we can see all the data entities. If we click in one of the data entities and then we click in one of the data attributes, we have here all the physical metadata, in this case the Snowflake columns that represents this data attribute. So if we click in, for example, the production one, we will have all the information collected by the Collibra connector for Snowflake, representing all the physical metadata gathered from Snowflake. And if we scroll down, we can see that this column is related with the table is part of, in this case, team product, and at the same time this table is also linked with the Snowflake schema is part of, in this case, publish sandbox, and at the same time this schema is related or linked with the production sandbox DB. So as you could see, we have created a global view where we link it from the data product to the data entities to the data attributes. Those data attributes linked with the physical columns representing these attributes, in this case in Snowflake. These columns will be linked with the tables, those tables with the schema, and this schema with the database. And more importantly, it ensures that data governance requirements are fulfilled and actively involves the business in assessing changes to guarantee alignment with business value. If we need to make changes to a published data product, the esynergy Collibra Adaptor simplifies the metadata change management process by automatically creating a new version of the data product. It also provides new versions of the data attributes and entities, ensuring a complete history of changes is maintained for full traceability and governance. The deployment process for this new version follows the same step we have outlined previously, ensuring consistency and alignment with the established data governance workflow. So let's start by changing the version of the data product in the dmconfig JSON, that is the configuration file we are using in order to provide details about the data product. So let's create a PR to merge these changes into dev. The deployment process is exactly the same we already explained in this demo, but this time, as we increase the version of the data product, this pipeline will create in Collibra a new data product based on the previous one, but implementing or populating all the changes we have performed on the data product. In this case, we haven't provide any kind of changes, but the new version will be identical to the previous version we have deployed. But in this case, the status will be again pending for approval, and the process will start since the beginning, implementing all the changes you want to apply. Now that the validation process has complete, let's merge the PR to deploy the changes into dev, and a new deployment process will trigger. the deployment process has completed successfully. So if we come back to Collibra and we go to the business asset domain we have created, as you can see, we have a new version of the data product, in this case version 2, and the status is pending approval. And all the entities defined are in here. It's important to mention that if an entity has been approved already or published, there is no changes on this data entity. The entity will continue as with the same status. So data stewards and data owners only needs to approve the new changes, but not repeat the entire process again and again, simplifying the deployment and the maintainability long term. I hope you found this demo of the esynergy Collibra Adaptor insightful. If you would like more detailed information or wish to arrange a personalized session, feel free to reach out to esynergy. We will be delighted to provide further details and explore how we can support your data governance needs.